Good evening, everyone. How are you doing?
Good night, Mr. Shand. Good night, classmates. Don't want to crucify me, so let me have manners.
You say, Chuma, come on already and say good night and nobody not answer me. Me just watch it, you know.
Sir, me just reached.
No,
Good
not
night,
you.
sir. Just sat down on the computer. Good night, sir. Good night, my
Good night. Good night.
classmates.
No, it's not you, man. I came before and said good night and but not came in the mind, but I want love still. All right, I'm just holding on. I don't even know if I should be doing this, you know. I'm gonna hold on for another maybe 5 more minutes for those of you who just come in. We'll put on the kettle, make a cup of tea, and let us sip tea together. I'm giving 5 more minutes to get yourself sorted out. All right, guys. While we wait on others to hold on. I think everybody's here now. Yeah. Everybody's here now. Yeah, everybody's here. This is the number I'm seeing consistently. All right. Based on what was done, I have an example two to give you. What do you recognize between this question that I'm giving you now and the ones we have been doing? Hello? Can you hear me?
Hearing you, sir.
I'm asking, what's the difference between this one that is being projected and the ones that
Observe.
we have been doing before?
Hold on. Let me observe a bit more, sir. The ones that we did before would have two values of x that we need to determine if it's continuous or not.
This one has?
Versus this one that has only one value that we need to determine if it's continuous or not.
What else that okay, so that is correct. What else are you recognizing?
We have two terms.
Two partial equations?
Yeah.
And the others we were given with three, right?
Yeah.
All right. Start this one for me, please. Let me know when you finish, please. Obviously, finish it.
No, sir, not finished yet. In a bit.
All right, cool.
Sir,
Uh-huh.
I am trying to remember or trying to figure out to see.
Mm-hmm.
Well, I think I find the answer. I think I think the response is discontinuous or something to that effect. My response is 0.
So you're thinking that it's discontinuous. All right, no problem. Anybody else?
Sir, I don't know what to do. I'm sitting waiting for you.
So same thing again, sir. It's discontinuous.
Okay, Shelly. What values you got for them? What value got to the left of 3? What value got for the left of 3?
Sir, 0.
And what value got to the right of 3?
-3.
-3, sir. Me no know what one with the mouse, sir.
Okay.
Hold on, listen. When you say left of 3, is it the top one?
I mean, no, you must tell me, Chevy. When I say left of 3, Chevy, what I mean? Which of them is the left of 3, Chevy?
Less than 3.
All right. So you're asking that for Brendan.
Oh, no, can we get -3 for that one then?
Or you get -3 to the left.
Yeah.
Hmm. What the rest I want to say? Because some people saying to the left they get 0. So talk to me now.
To the left would be -3, which would be the top one. And then to the right would be 0, which is greater than or equal to 3.
All right, so I'm here. Dre. We're not hear from you tonight, Papa.
Sorry, sir. I get the opposite. I get to the left, I get 0. So unless I'm doing the wrong equation, that's why.
And that's why I want to. That's why I said what I said to Chevy, because I want people to know what is the left and what is the right of the equation. All right, problem. Hear from you. I heard from Tristan just. No, Simon, Sabrina, can you unmute for me, please?
Sir,
Good night,
Kenny. Good night.
It's the first time I'm hearing your voice.
Because my baby's always crying.
Make the baby cry. Make me hear the baby cry. Me want hear your voice. Me want hear your voice. Where you get for the first one?
Sir, hold on. I'm looking my book. Wait.
It's alright. Mute. Mute.
Jesus,
Yeah, mute. It's alright. Me don't want it again. Mute. Jesus. Boy. Simon, what say you?
Yes, sir. For the right, 2x minus 9, I got -3. And then for the next one, 2x minus x minus 3, or is that for the... Sir, I need to work on the left and right, but I got 0 for
that's exactly what I need to do. All right, thank you, Poppy. All right. Just a word of encouragement for those of you who are in a noisy background. I'm going to ask you to try and find a nice little place so that when we're unmute, we don't hear those colorful languages here. All right, thanks. All right, so I recognize that people are getting this stuff. Yes, it's discontinuous, but people don't know which is left and which is right. So I am pleased with. I'm very pleased with the discontinuity. People are getting 0 and 3, but people don't know if it is the left is 0 or the right is 3. All right? Now, let me go through that exercise once more. To the left means less than. And it's easy to remember, you know? Look, left begins with L, less than begins with L. So L for L, if it is not to the left, that means it's going to be to the right. And if it's to the right, it's going to be greater than. And one of the things you can look for the greater than is that R ends with R. So one starts it, one ends it. So once it is to the right, there's no R in less. There's an R at the end of greater. So if it's right, it's greater than. If it is to the left, it is less than. If it is to the left, we use a superscript minus sign. If it is to the right, we use a superscript plus sign. And we always read from inside out. We always read from inside out. X is greater than -2, but it's less than or equals to +2. All right? So, because this is x less than 3, it means that this equation 2x, the 2x minus 9 is to the left that we're investigating. And x is greater than or equal to 3, because it's greater than, it means this one is going to be to the right. Now, let me just warn you on something. Even though I'm hearing from the class, left and right, not left and right. I'm getting from the class 0 and -3, sir, and it's discontinuous. Don't feel say get the full marks. Because if you put to the right to be -3 and to the left to put 0, you're losing mark for that. Because it should be the other way around. So you have to know which is which. Am I clear?
Yes, sir.
All right, good. All right. And to the left, it's going to be, as I said before, 2x minus 3. What we're going to be doing anywhere in the function, we see x, we put 3. So it's going to be 2 times 3, 6. And 6 minus 9 is -3. And to the right, it's going to be 3 again. Wherever you see x, you substitute 3. 3 minus 3 is equal to 0. So since the limit to the left, see here, 3 superscript minus, the limit to the left is not equal, that sign means not equal, to the limit to the right, it means that it is discontinuous. R of x is discontinuous at x equals 3. All right.
Sir,
Yes, my love.
in the please note section that you showed us the last time and you showed us just now, the plus VE that you have in the bracket, can you remind me what it means, please? And the minus VE.
What are you talking about? This piece here?
No, scroll back to the please note where you were showing us how to determine what is left from what is right.
The dash IV?
Yeah.
Is negative.
Negative VE,
and the plus IV is positive.
So, okay. All right, sir.
Yeah, so it's just a shortening. For negative, it's BAM VE. Negative, positive. So the plus means positive and the minus is negative.
Okay.
Okay. No problem. All right. On the mark, get set, go. Determine if f of x is continuous at x equals -2 and x equals +2, given that function. On your mark, get set, go. Let me know when you finish. Who is SAMC? Please, can you rename yourself for me? Student who just entered the class, SAMC. Can you identify yourself for me, please? Are you all hearing me? I'm not sure.
We're hearing you, sir.
All right, so for the third and final time, before I put you out of the class, SAMC, who are you? Okay.
My apologies. Oliver, I came in on a different device.
Okay.
My laptop
No,
stopped
it's
working.
all right, Oliver. It's just that I need to, for security purposes.
Yes, I understand. So let me see if I can change my name quickly.
You know,
Sorry.
I'm renaming, Oliver.
All
What's
right,
your last
thank
name
you.
again, please?
Mackenzie.
Mackenzie?
Yeah, apologies.
No problem, puppy.
Sir, in the exam, are we required to write out all of these sentences at the end of the responses?
Of course, it's a part of your response. It's a part of your response, yeah, man.
All right, I'm finished, sir.
You finished? Anybody else?
Yes.
What did you get for your answer?
Me are the first person.
Whatever.
For me,
Come on, guys. Come on, man. Don't
for me,
stop
sir,
the crap. Yeah.
at
Don't
x
stop the crap.
minus 2,
Mm-hmm.
it's discontinuous. So here's the reason it's discontinuous. So since 3x plus 7 is not equal to x squared minus 5, when the function f of x equal minus 2 on the left and x minus 2 on the right is discontinuous at x equal minus 2. So I got -1. I got for the x squared minus 5, which is on the right, I got -1. And for x squared minus 2, sorry, for 3x plus 7, I got 1. That's on the left.
That's what I got as well.
And for x being x at x equal 2, x extending on the left, at x squared minus 5, I got -1. X extending to 2 on the right, where 5x minus 11, I have -1. So since the limit of x squared minus 5 is equal to...
All right. Hopefully you're hearing me. This other device does not have the audio does not work too well. I got disconnected from my speaking device. I'm not hearing what it is that you're saying. Just give me a minute, please, so that I can re-enter using that device.
Hearing me?
Apologies for that, please. Thanks.
Okay.
Sorry. So you're saying no AC? Go again for me, please.
What did you miss? What does you heard?
You were saying, so you were giving the statement. Just read the statement again for me, please.
Since the limit x squared minus 5 is equal to the limit of 5x minus 11, the function x equal 2 on the left, x equal 2 on the right is continuous at x equal 2.
What you gave me just now? You gave me 2 sets of answers a while ago? For both -2 and +2?
Not a while ago, but I gave you -2 first.
Okay, all right.
That's why I asked what was the last thing that you heard, because when you pop in, I was at +2.
Okay, all right.
Yeah.
Is there anyone in the class that agrees with her?
Yes, I agreed.
Okay, Oliver. Tell me now, Oliver. Let me hear your statement. You agree with her? Let me hear your statement.
As in starting from x is equal to -2?
No, man. Your statement. Your statement to say that it's either continuous or discontinuous. Remember, sir, always have a statement. What is your statement?
Oh, yes. Since the limit of x, since the limit of x squared minus 5 approaching from the left-hand side is equal to 5x squared at minus, as the limit approaches positive 2 from the right-hand side is the same. The function is continuous at x equals 2.
Okay. All right. You see, those of you who are not, when I ask a question and everybody sit down, I don't want to slow up my class because I am moving rather very slowly, and I have your exam paper was submitted, and I know I have a whole lot more to finish off. So please, when I ask a question, just unmute and just answer quickly. You guys are struggling with your statements. You're struggling with your statements. So at x equal 2, and I need to clear that up now. The limit as x tends to negative 2 to the left, listen to what I'm reading. The limit as x tends to negative 2 to the left, which is 3x plus 7, is going to be anywhere in the function I see x. I'm going to substitute negative 2. So 3 times negative 2 is negative 6. Negative 6 plus 7 is going to be positive 1. Now I'm going to evaluate to the right-hand side of the limit. Since I already evaluated the left, like the intuitive approach, I must investigate both left and right. So the limit as x tends to negative 2 to the right, which is x squared minus 5, anywhere in that function I see x, I put negative 2. Negative 2 squares is going to be positive 4. 4 minus 5 is equals to negative 1. So since the limit as x tends to 2 to the left is not equal to the limit as x tends to 2 to the right, then f of x is discontinuous at x equals negative 2. Did you get it to be discontinuous?
Yes, sir.
Do you have a clearer understanding now how I'm reading my statement?
Yes, sir.
All right.
I
Yes,
have it
please.
written the same way, except I don't have the x extending to minus 2
To
on
the
the
left.
limit.
You must.
So I have it in there, but I don't have it underneath it.
Yeah, but you have to tell me. You have to identify what you need to do. You notice I have x tends to negative 2 to the left, and then I have my equation 3x plus 7.
That's how I have it.
Good, right, very nice. Because
But
I
what
need to
I'm
identify which is which. Yeah, go ahead. Let me see
But
if I
what
get
I'm
you now.
saying, I think I made the mistake where you have, since the limit x extending to minus 2 on the left, I don't have the x minus 2 underneath the limit. Instead, I have it in the statement, but not under limits. I'm not sure.
Okay, right. I get what you're saying. So, for you to complete the statement for the limit, though, so the limit cannot exist without that there's something underneath it to tell you what it's going to.
Okay, sir.
It's just like you cannot just eat rice and peas and fish. It has to be rice and peas and chicken that you eat on a Sunday. That is just the national dish. I just saw it though.
No.
Who eats rice and peas and oxtail and them something here? No, it's supposed to be rice and peas and chicken. What else do you eat on a Saturday for dinner?
Anything I feel like eating?
No. What the Saturday dinner supposed to be?
Normally people would say soup, but because I got church on Saturday,
It is soup. It is soup. So the point I'm making is that some things are just understood and some things are understood. So without having the limit, the definition under the limit, written under the limit, it is incorrect. Let me tell you why it is important for you to put it. If you're an architect or a draftsman, when you're writing the date, you can't just write 9th of the 9th, 2023. Negative. Because if somebody wants to set you up, the person can write 19th of the 9th or the 29th of the 9th, and it messes you up. So if in what you do, you write your 0909. So nobody can mess up when you do them things there. Very important. Very, very, very important. All right. Somebody else was coming in to say something?
Yes, sir, it was me.
Mm.
Why you use those two equation to determine if it's continuous or
Why you're asking me why is it that I selected those two equations?
yeah.
Okay, look at the third equation and tell me what's the condition for the third equation, Oliver.
Could you repeat what you said a while ago?
No, I'm saying look at the equation and tell me what is the condition for the third equation in the function.
Is the third condition greater than or equal to 2?
Yes,
Right.
greater than or equal to 2.
Greater than or equals to 2. But what are we looking at, Oliver?
-2.
-2. You see it, Oliver?
Yes, yes.
Mm-hmm. So we can't use the third equation with -2 because the third equation says 5x minus 11 such that x is greater than or equals to +2. So the only two equations we can look at are the first and the second. The first one, 3x plus 7, is looking at to the left of 2, of -2. Sir, how do you know that it's to the left of -2? Because it's less than. L for L. Less for less than. So because it is less than or equal, sorry, that's less than 2, -2, it is to the left of -2. And then the other one says x is greater than -2, but less than or equals to +2. Now, because x is greater than -2, greater than is going to be to the right. So that's why I have this here, this 3x plus 7 with a superscript negative. The negative is saying to me, yo,
it's
to the
coming
left.
from the left.
Mm-hmm. And then the superscript positive is saying that I'm coming from the right. Let me see if I can explain this a little further to see if you guys can understand it. Anybody ever be going to an unknown place, an unusual place? What can you tell me about the journey going to and the journey coming back from?
When you're going, sir, it's very
Mm.
far. When you're coming back, it's easier. It's an easier travel. It looks closer because you know where you're going, because you know where home is.
Very good. Very good. So it appears to always take very long when you're going. But when you're coming back, you can say, it's easy, Jesus. No, some people who live in Linstead, let us say that we all live in Kingston. Some people who live in Linstead and have to traverse from Kingston to Linstead every day say, but it's not far. I said, Jesus, to go through Spanish Town, to go through Angels, then to go through the gorge. No man, it's far, man. But you take that trip 2 or 3 times to the week, and it come like nothing. Come like nothing. I was in Hanover, and a family member said, about how long it take us man for reach back to Kingston? So boy, it's about 4 hours, you know. Them say which 4 hours? Half an hour from yesterday for go Montego Bay. I said, which car? And who is the driver? I said, no, it's gonna take about an hour plus to get to Montego Bay. Him say, no, a half an hour or less it take we from here so. And this is almost at the border of Westmoreland I'm talking about, in Hanover. To go to Montego Bay, I said the blood is against that thought.
Yes,
Him say,
sir. It's about 30 minutes through.
go away. Go away. Your legs
Sir,
are
it's
heavy.
about 30 minutes through, sir.
AC, your legs are heavy. No, it's longer than that.
I was told.
No, it's longer than that. And then now the family member was saying, anyhow, I don't know where the police them there. That's why we know where the police them there. So we know when to speed up and when to slow down. I don't know where the police them there. So me I take my time. Them say 80, I drive 80. Them say 60, at 60 me I drive. Because me not give no police no ticket, no more money. Me not give the government no more. Them taking enough money to my salary.
Speed
So-
up with a bonnet.
So the point is, coming from the left side is going to be very different from coming from the right. So you have to be very careful to tell me which equation is representing the left and which equation is representing the right. You have to practice that. That is when they separate a grade, an A from a B plus, and a C minus from a D plus. You have to tell me the correct stuff. So you have to get your practice. I have more to give you, because I'm building you up now to drop something on you tonight. It's not difficult, but I'm building. Remember I said to you that that's the end of the topic. But I'm building and I'm building. So let me just tell you what it is that, oh no, before I do that, let me just finish this and then tell you what happens. All right, so let me just project this one here now. So at x equals 2, I'm going to look to the right of x equals 2 and to the left of x equals 2. Look here. The mere fact that this says 2 and 2, can I use the first equation again?
No, sir.
Why?
Because it says less than minus 2.
It says -2, and I'm not dealing with -2 anymore. I'm dealing with +2. No, the last equation that speaks of 5x minus 11. The condition is such that x is greater than or equals to -1. So the mere fact that it's greater than -1, it means that it's going to be to the right of -1, of +2, sorry. Because it is greater than 2, the greater than means that it's going to be to the right of 2. Now, somebody may say, then sir, suppose the x squared minus 5 is also to the right. You can't have two of them to the right. If you're doing your intuitive approach, something has to be approaching from the left and the right, and you compare them. If the limit from the left is exactly the same as the limit from the right, then you're good to go. Otherwise, discontinuous. So what I'm saying to you here is, the mere fact that coming from the right-hand side and the left-hand side produces -1, it means that the function f of x is continuous at x equals 2. The function is continuous at x equals 2. 2 questions so far. Any question?
Sir, a question nothing related to this topic per se, but Educosoft.
Thanks for reminding me. Can you remind me before the end of the class, please? At 9 o'clock, remind me, please.
I'll try to remember to remind.
Yeah, no, man. Somebody's in the class, just put a reminder down for me on your phone or something. Who was it, Lord? There are 2 students who reminded me. Andre was one of them, and then somebody else sent me. It could be Tristan. Tristan, you had said something to me about it, right?
Yes, sir.
Yeah, man. It was Tristan, yeah, man. So at 9 o'clock, one of the 3 of you or anybody from the class, just definitely please. So I can do what I need to do. All right. Quick and fast. We're running this thing now, Now that you know what to do, quick and fast. As soon as you're finished, unmute and say, sir, I'm finished. Don't sit down and wait. As soon as you finish, let me know. On your mark, get set, go.
Wait, we do a one already, no, sir.
I gave you that one already?
Hold on, hold on.
No, man.
No.
Mm-mm.
No, sir, never get.
All right, continue.
Finish, sir. X equal, sorry. Since the limit of x extended to 1 on the left-hand side, using the equation 6 minus x is equal to the limit of x extended to 1 on the right-hand side, using the equation 2x plus 1. F of x is continuous at 1 equal x equal 1.
2x plus 3.
Yes, sir. 2x plus 3. What did it say?
Said 2x plus 1.
Yeah, I'm sorry.
Anybody agrees with her?
Yes, sir.
Nice job.
Yeah.
Is there one in the class that is still not seeing what it is that we are doing? It's really not difficult. And that's why tonight you are taking the show for the class. I'm only presenting the questions. Oh crap, did I do this other one that I'm going to give you? Maybe not. Oh man. And I can't do it right now because I'm going to project. All right, so that's the reason I am projecting and having you do the questions so that you can get sharp at it. I am not seeing you. I don't know how many of you drop asleep. How many of you are following? But I asked the question a final time.
Sir, I am here. I'm following. I'm getting it now.
Very nice, Nikki. I'm happy. All right. The rest
Yeah,
of you,
man.
if you're not following, there's something. Go ahead, please, sir.
Yeah, man, on a sleep time yet, man. We'll follow, man.
Same way, sir. Thank you, Oliver. Bless up. All right. Okay. Warm up. Low.
Lord of mercy.
Pull up selectors. No, this is what AC talks about. And she can't say it, but I'm give some easy one. So she can't say yes, man. I say them stay, man. Let me get the easy one.
I mean, I said nothing, never look fine.
I love it. All right, come guys. Chevy. Yeah, oh, it's a silent in it, Papa. One to you.
Yes, sir. No, yes, sir.
All right, cool. Make sure. Dre,
If we go to one of them already.
if you
Yeah,
want to know
man.
already, nice. Dre, oh, you
Yeah.
stay. It's a
Yep.
silent, Dre. It's
No,
a silent
I'm
tonight.
good. I'm good too, sir. I
You good,
realized
bro?
what I did in the first block, but I start getting it now.
Good job. Nice. And Nikki answer me already, and Brina can unmute, and Simon, how you stay?
Yes, sir, I'm alright.
Good. Tristan?
All right, sir.
All right, very nice. Let us see who first can finish this one correctly. Not just finish it, but finish it and get it right. On your mark, get set, go.
Sir, me stuck.
All right, so we can try. Whoa. So Sir Gandu drink water.
Oh God. Nikki saying something?
Yes, sir, we can try.
Go right ahead, my love.
God, they're ready for laugh now, so sir, this is what I do. Since the limit of x squared minus 1 over x minus 1 is not equal to the limit of 5x minus 3, then p of x is discontinuous at 1. You hear me, sir?
Me hear you, but the rest of them are not hear her.
Yeah, but the TV distracting.
All right, I turn it down.
We don't know only learn that in the noise, you know.
I'm slightly different.
You are slightly
Can you hear
different.
You not
So
finish.
Nikki, you said that at x equals 1, it is discontinuous.
Yes, sir. That's what I said. It's discontinuous.
Oliver say him have something slightly different. When
Sir,
you get
I
Oliver?
was heading slightly different too.
Okay.
What am I do? We see the difference of squares.
Right. I'm a stop.
So you end up with x plus 1, x minus 1, which you're going to cancel the x minus 1 from the top, from the bottom. You end up with x plus 1. And then your x plus 1, you substitute 1 in, so you end up with 1 plus 1, 2. And then you do the same by approaching to the from the right by putting the x equal 1 into 5x minus 3. So you end up with 5 minus 3, 2.
Okay. Anybody has the same thing like what Oliver has, or you have what Nicole has?
Sir, I was heading to where Oliver was. And I kind of ease back a little bit.
I do the same thing that Oliver did. I factorize, and then when I factorize it, I get I get the continuous.
Okay. So Oliver, Dre, AC, so continuous. Nikki said discontinuous. Who else?
Sure, it's continuous as well, sir. I got 2 for both of them.
And Chevy say continuous. Who else? Bree, what you say? Tristan, what you say?
Sir, discontinuous.
You're saying that it's discontinuous. So you are siding with Nikki to say it's discontinuous. Okay. What say the rest of us? There's like 2 more people to answer.
Sabrina says continuous.
Sabrina says continuous. Simon, what you say, Papa?
So when I saw the 0 over 0, I knew, but I'm gonna say discontinuous.
When I said discontinuous. But let me ask you though, Simon. You said 0 over 0. Where did you get that 0, 0 from?
Sir, I got it. I'm from the 1 squared minus 1 over the x minus 1.
All right. So we're gonna have a conversation about that one. And again, this is why, and I'm happy that you said that, Simon. Again, students, I'm saying when you have a thought in your mind, I need to hear that thought because I'm able to say whether or not you're on the right track. I'm able to say, yeah, man, expound on that or normal left us alone. Let me ask the class. At what point in time, when do we reckon, when do we encounter 0/0? When what?
When we need to factorize what another that you want here.
No, that one I want here.
Emma will come again.
I say indeterminate, I said indeterminate.
Yeah.
Yes,
when it's indeterminate.
Indeterminate.
And when it's indeterminate, what type of limits are we looking at when it's indeterminate?
Sir, I'm not sure, but I know at that point we factorize because it's saying that it needs to extend. So something is.
Yeah, man. Before we reach the factorization, there's something that is there. Even before we reach the indeterminate, there's something else that is there. How do we know that we are really talking about something that is indeterminate? What must happen to the limit?
As it approaches in infinity.
Infinity, yes. So Simon's son, this one here is not approaching infinity, This one here is approaching 1. So we can't use 0/0. 0/0 is to be used when we are referencing something that's indeterminate, and we reference indeterminate when we find the limit of a function when the function is tending to infinity. And we have a rational function, 0/0. I mean, numerator and denominator. Because I can give you a function that goes to infinity that is not a rational function. It's what we call a polynomial. So you have to be very careful. You have to be very meaningful in dealing with that. So I'm happy that you said that. I know you won't say it again, but tell me now, what happens at x equals the other variable? We look at that one and we got it to be continuous. Oh, by the way, before I do that, Nikki, you see why it is continuous now? Hello, somebody? Nikki, you hear me? Anybody hearing me?
She said yes, she's hearing you, sir.
Oh, okay. Yeah, I'm speaking, I'm not necessarily looking down at the phone. So all right. Right. So it's going to be continuous because we are doing our calculations. Now hear me out. A question like this in the exam carry about 10 marks, A plenty marks that. And we cannot lose 1 mark out of the 20 marks, out of the 10 marks. We want every bit of it. So that's why it's important for you to write this tending to this, to the negative and to the positive, because you do get marks for those stuff. And you leave it out, you're going to be in problems. So we don't want you to be in problems, so don't leave it out. All right. So look at my calculation. Yes, Oliver, I hear you. And what I hear from you, Oliver, is exactly what it is that I have. You recognize, oh Lord, forgive me. You recognize the difference of squares. And that's where I want the class to go. Big school mathematics is, I'm a primary school with them, and a big school. So I want to start speaking like big school people. You heard the man say? Sir, I recognize the difference of squares. Me recognize it to see yourself, difference of 2 squares. The man says, sir, you project something in class day before yesterday and talk about difference of squares and perfect squares. So I recognize the difference of squares, sir. And when I factorize the difference of squares, I recognize that the x minus 1 in the denominator will cancel with the x minus 1 in the numerator. So technically what I have there working with, sir, is x plus 1. And if it is tending to 1, anywhere in the function I see x, I put 1. 1 plus 1 is 2. So the limit to the left of 1 is tending to the 2. So we're going to try the limit now to the left, to the right of 1 and see what it goes to. The limit to the right of 1 is a function 5x minus 3. How you know that, sir? Because the inequality says x is greater than or equals to 1. So it's greater, it means it's positive. So the limit to the right is going to be 5x minus 3. Anywhere in the function I see x, I put 1. Why 1, sir? Because the limit will go to 1. AC, you see why I tell you say it's important now if you name something? One of the things that I'm sure you don't like is someone looking at you and calling you girl. You have a name. I know some people who, if you call them, hello, Miss Appleby, them stop and tell them my name is Dr. Appleby. Because them earn it. And put on some clothes for your salutation. Doctor them name now, a doctor you have to call them. All right. So I'm proud of you, Oliver. I loved your explanation because what it says to me is that you are thinking outside of the box, which is where I want to get you guys to go. All right. So since the limit on the left is equal to the limit on the right, it is continuous. What say you for x equals 2? Is it continuous at x equals 2?
Yes, sir. It's continuous.
All right. Let us check. Voila. It is also continuous. Did you get it to be equal to 7 both ways, to the left and the right of 2?
Yes, sir.
Mm-hmm. All right. Is there someone in the class that is, I've gone through about 4 or 5 questions so far, I think it's 4. Is there somebody in the class that still has not seen what it is that we've been doing or needs a little bit more time or whatever it is? Speak now.
Sir,
Go ahead.
for me, it's just some small things, which I keep saying on class. It's just some small things. Because even with the perfect square, I identified, but then I keep baffling over it. So
Even with the difference of squares.
yes, sir. I left the space and I started the process, and the confidence couldn't come up to bring it to surface. I just need to work on that part for me.
Very nice. Is there somebody in the class that somebody else in the class that something that's not clicking yet? Remember, you know, if you're not following me in class, you know, you don't say nothing, you're stupid. No apologies. But if you not follow, I say, hold on, sir. Hold on. We not follow you, sir. You're sensible, so till. And I'm serious about, I want you to stop me and ask me questions. I want you to engage me. I want you to engage me. That's what I'm being paid for, and that's why I'm here. Talk to me. Talk to me. Just talk to me. Okay. So you will recognize that when I teach, I move directly into past papers. Oh, Lord and Father of all mankind. You remember AC, I was saying to you that I am building, and I'm building. Now that I've reached my crescendo. I am now at my crescendo. This is where
not music.
Huh? Trust me, it's the music of mathematics. I want you to look at that question because I mean, you guys are going to work the question with very little help from me tonight. I built and I built and I built. This is past paper 2017. Let us go to the question. It says, a function f is defined as follows. F of x is equal to all of them 3 or something there. And it says, determine the values of a and b. Rockstone. So you never done a question like this before? Not technically, but yeah. Such that f is continuous over the interval x is greater than negative infinity. but less than infinity. Oh, Rockstone, that's the whole range, sir. Yes, the whole range. What's the first thing you think comes to mind? Talk to me. What's the first thing that you think, you should be doing?
Factorize.
I hear somebody say factorize. Is me talking to when it's a factorize?
Why?
I feel.
Oh, so you said factorize. Let me ask you a question though.
And this first one, equate that to that and that to that.
How does a factorization help you in this case? You see, in the last question we just did, when Oliver said, I recognize the difference of squares and I can go and factorize, it can help. Because you see, same I want x minus 1 in the denominator, talk truth.
Yes, sir.
Yeah. I'm gonna cancel it out. But in this case,
So,
if I
sir,
factorize
in this, sir,
no.
in this case, you're gonna use when you find the two numbers, you multiply to get the negative 4 and you add it to get the 2.
Yeah, but I'm saying that there's no need to factorize in this case. That method that you're talking about with the factorization is the correct method of factorizing. But I'm saying for me to do that in this case, does it make sense? And my answer is no. Doesn't make any sense. Why, sir? Because you don't have anything to cancel with anything. You're just going to factorize and waste time, precious exam time to factorize. It's not going to give you a cent more on your dollar. Why do it?
All right, sir. Looking at it, it says that x is less than to negative infinity, or x is greater than infinity, the positive side. So what I would do is randomly select a number and substitute where x is. Starting at, let me see, starting at 2x squared minus 4x plus 2, and see where it takes me from there.
Mr. Sean.
Yes, please.
All right. Here one more thing. All right, at x minus 1, right? Substitute x into the first of the three equations, right?
Substitute x?
Pardon?
You said substitute x?
Minus 1.
Okay, thank you. No, you're correct.
Yeah. Then at that point as well, I am working with minus 1. So I put the minus 1 into the second equation and have, is that almost similar to like simultaneous equation almost. So I'd put the minus 1 into the ax plus b at that point now, and then now when I move to the other one now, I now leave the minus 1. I go to x is positive 1, plug it into 5x plus 7. But this time now, at ax plus b now, instead of using a minus 1, I use a positive 1 there. And then now I try to work down what a and b are at that point in time. Because I'm going to have two sets of, I'm basically going to have two equations there.
I was going to say something to you, Oliver, but then again, I remember that we're a Methodist institution. Because I already sinned in my mind, let me verbalize the sin. I was going to say to you that I was going to buy you a red stripe beer, but my principal may not be, okay with that suggestion. So,
Malta.
No, me no want to go drunk you. Me go buy a bottle of water.
All right.
I'm proud of your reasoning. I mean, you were off one or two places, but I asked a question just to get you to start thinking, and I see where your thought processes are leading. And I'm saying to you, students, I'm using a different approach to the teaching of Calculus 1 this semester. Because there is no reason you can sit in my class based on the questions that I ask and the things that I will say to you, do it and come back to me, that you should fail. So I'm proud of you. No, let me just correct before I even project. No, let me project first. By the way, let me ask, is there anybody else with a suggestion? Oliver gave something very close. Anybody else has a suggestion? I don't want to not use your suggestion. Let me know, please. If not, I'll just go on.
Continue, sir.
All right. So just like we did in the other examples, which is what Oliver is saying, we're going to investigate where x equals 1. Just like what he's saying there, that we're going to look to the left and to the right of the limit. When we look to the left of the limit and we substitute that 1 into the function, he said...
Excuse me, sir.
Go ahead.
Why are we using -1 as x? I'm not sure if I missed it in the question, but I don't see it given in the question. That's the reason I say a random number. So
Okay, all
why
right,
are
no
we
problem.
using -1?
Excellent question. Very nice question. I'm going to throw it to the class. Why are we using -1?
Because we want to confirm that it's continuous at those points. So even for it to be continuous, you'd have to basically how am I say this in words?
All right, let me help you out here.
You can't verbalize it, so let me leave it alone.
You know, yeah, and I appreciate it, Papa. I really appreciate it. Incidentally, I just went, before I forget, I just went on Arian and looked, and there are only 3 of you that have selected my class or are registered. And one of the students I recognize but has not started classes yet. I'm hoping that, next week is, but school reopen on Tuesday, so we're gonna have class Tuesday. So hopefully by Tuesday, I'll see that student coming back up. No, so AC, you're saying that normally the question says, is a function, and they tell you where it is, x equal 1 and x equal 2. Look at the question and see if you see any resemblance of this x equal 1 and this x equal 2 AC.
Seeing the question, okay, not showing it. You mean in the condition? That's where you
Sit here, yeah man, I'm showing it, sit here. It says determine if p of x is continuous at x equal 1 and x equal 2. And I'm saying look within the function p of x to see if you're seeing this x equal 1 and x equal 2 business.
in the condition.
Over here, so don't.
Yes, sir.
So what may I say to you that I don't have to give it this at x equal 1 or x equal 2. I can say determine if p of x is continuous given that p is equal to that. Because you have to use x equal 1 and x equal 2. Sir, how you know that? See that so? Boom, 1 right there, so. Boom, 2, boom, 1, boom, 2. You know, I have no other number but 1 and 2. Let me go back up further. So I'm happy you asked the question, you know, and that's why questions are made to be asked, you know. So if x equal 1, watch this. X is less than 1, x greater than 1. We can't do 2. And we can't do -1 because that's not what it's asking for. The condition says 1, so it will go work with. Watch our one here again. Last one I look on. The one I say -2 and +2, me not have to watch it right there. So I watch it over here. So see the -2 here. Look at how I'm going to get the -2. I draw one slant line. You see the -2 cut each other, right here. So I draw it so. And look on the +2. Boom. So the line up. They literally line up. Well, this one line up straight down.
So the condition determines the limit then.
Yeah. Yes. You see what is happening? while we're doing the questions, everything coming out aha moment a while ago, you know. Yeah, man, very nice. Very nice. This is what I want to happen on a Tuesday, Thursday. All right, so watch me now. So at x equals 1, I am going to, so you remember, you know, we then never tell us that given x equal 1 and x equal -1, you know. But we know, say, we're looking at the conditions, and the conditions say, no, next, less than -1, no, greater than -1, and then less than -1 and greater than or equals to +1. So we know, say, -1 and +1 I'm talking about. We know, we already know. How we know? We're bright. We look on the conditions and know, say, a 1 and -1 to talk about. So as a result of that, I now have to investigate this -1 and this +1. I have to investigate it because those are the conditions for which I'm going to be working. Watch me. I will name -1 and I'm going to ask myself the question, what is to the left of -1 and what is to the right of -1? And I'm going to ask you to answer that question. What is to the left of -1? What function is to the left of -1?
2x squared minus 4x plus 2.
Excellent, Florian. Yeah, man, very good. And what is to the right of -1?
AX plus B.
Yes, man.
And 5x plus 7.
Yeah, man. Oliver, I'm going to give you another opportunity now. So now, Oliver, you know that we're doing it the same way. And I'm going to look to the left of -1. And I'm going to substitute my 1 anywhere I see x into the function 2x squared minus 4x plus 2. And then I'm going to do a similar manner, looking to the right of -1, where anywhere in the function I see x, I'm going to substitute -1. So it's going to be a times -1 plus b. I'm going to give you an opportunity now because you also made mention of something that is very important. Yeah, I never want to call the name again, but now that you call it again, use it. Yeah, the simultaneous equation. What is missing? Just give me one thing that is missing right there and then I move on.
0.
0. How do you know that is 0 though?
Simultaneous equation always equals to 0.
Okay. I'm gonna give you 2 minutes to think what it is that I'm gonna do. Listen to me now. And I'm not going to tell you the answer tonight, you know. The question here, I'll go come on your final paper. It'll go come on the mid-semester that is coming up. I'm gonna give you 2 minutes. If you want to talk it through the classmates, I don't have a problem. But I'm gonna give you 2 minutes for you to tell me, for you to respond to my question. What happens after I make the substitution to the left and right of my -1? I give you 2 minutes, so don't talk yet. Take the 2 minutes, look at it, jot down something, and I'm going to call upon someone to respond to me. 2 minutes.
And in that 2 minutes, sir, remember the
Oh, it's 9 o'clock now. All right, cool.
after
After the 2 minutes, remind me again here. All right, thanks, love.
Sorry, 2 minutes up. Because it's going to take more than 1 hour for me get this. So sorry, the 2 minutes is up, please.
Anybody have a suggestion to me for me now?
All right, this might sound like crap, but because we're trying to determine the values of A and B, I would say that we would start by looking at AX plus B equals 0 and 5x plus 7.
Okay. All right, I hear you. Any other suggestions?
Sorry, so you're gonna use simultaneous equation, correct?
Well, I didn't say that. Oliver did.
Okay.
Yeah,
Because
man.
in simultaneous equation, you cancel one, use one equation to cancel the next. So
but you're gone way ahead. You're way ahead. So let us just back up a little bit. Any suggestion? Any further suggestions? Talk to me now. Drake, talk to teacher.
Sir, I don't have any suggestion at the moment. Because I was thinking that once you work out the first line, which is the left, the limit that tends to the left, which is 2x squared minus 4x plus 2. Once you get that value or whatever you get for the answer, you would have an equal for the ax plus b, because it says determine that the value of a and b as such that f is continuous. But I started talking foolishness now, so I didn't stop right there.
No. Don't you ever dare do that in my class. Let me tell you, say talking foolishness.
Okay.
You don't determine that.
Okay.
So let me go back to you now. So you said something that kind of struck my interest. So you said that you're going to find the limit as x tends to -1, and you're going to substitute -1 into the first function, right?
Yes.
And then the answer you get with that. What do I do with the answer that I get with it?
I was saying that it would mean, or it should determine, that ax plus b is equal to that answer, seeing that the statement is saying that the value of a and b as such that x is continuous or something.
And when it is continuous, what happens?
The left and the right are supposed to be equal.
So come in, say you understand. Don't you ever dare come to my class again and say me talking food. Me tell you say it's rubbish this talking.
There, when it's coming out of the brain, it doesn't sound logical.
And it's all right. And that's why I want you to speak in my class. You notice from day one I say I'm encouraging people to speak because I want to know what is inside of your headspace. I don't want to come to any day me have to come to the class and give you all of the information. It's the last day me teach you. I want you to be able to use your headspace. No, you are correct. So Oliver came up with something. Started off beautifully. But that's where Oliver made a mistake. That's why I said to him that some parts of it I don't fully agree with him because he never said it exactly like you said it. Now, let us go back to what is happening here. And congratulations to the pair of you and others too, because I'm hearing the conversation. AC, I'm going to come to you because he said something that I need to correct also.
Sorry, before you continue, sorry, I just wanted to confirm, is this going to be available, the recording? Because I have to leave where I am right now.
Oh, where you go? No, you can't leave yet, brethren. No, my, no. Tell your driver, whoever wait upon you, say, give you 10 more. No, man. I just get nice name.
It's more of security saying that I need to vacate the place now.
Brethren, man, you can't, you left the place when the party just start.
That's why I'm asking if you're going to have it recorded.
The recording, I upload the recordings in. I don't know if anybody watching the recordings in, but yeah, the recordings are uploaded. All right, if you have to for security, your security comes first. All the best.
All right, thank you.
Easy. So, what was recommended is that, just like we've been doing for all the other questions, if the function is continuous, it means say to the left and the right must be the same value. And the pair of them articulated that very well. If the function is continuous, it means that to the left and the right of negative 1, those must be the same value. So we're going to work out what is to the left of -1 first and see what value we get. Any value we get there, which is what Dre just said to us, anybody that we get there must be equal to the value that we get when it is when it is to the right. Because if the function is continuous, both left and right must have the same value. You see that the function is about good behavior. So anywhere in the function to the left, I see x, I'm putting -1. So 2 times -1 squared minus 4 times -1 plus 2. -1 squared is 1. 1 times 2 is 2. And I multiply 2 negative numbers, I get a positive number, so it becomes +4. 2 plus 4 is 6, plus 2 is 8. And I'm saying to the right, I'm still going to put this -1. 8 times -1 plus b. 8 times -1 is -a. b stands alone. It must be equal to the 8 as well. Why, sir? Because it says that it is continuous over the interval. We need to find the value of a and b because them tell us that the function is continuous. Now, if the function is continuous, it's going to be equal to a. It's going to be equal to the same value from the left that it is from the right. AC, let me correct you on something. You are very warm, and then you went way off track. Let me tell you where you went off track. The first part you did say correctly. You're substituting x equals -1 into the function. And then in the first instance, you said to me that you're going to put ax plus b equals 0. And I thought to myself, why would you say that? And then when you went a second time, you said the value that you get for ax plus b, you're going to set it equals to the 5x minus 3. 5x minus 3? The 5x plus 7. And I thought to myself, why are you doing that? But does this make any sense to you at all? Talk to me, let me know.
Yes, sir.
That's all that we've been doing since Monday, Tuesday. Now, similarly, we have something that is, we have the -1 with work, we're done with that. We have a +1, so we need to investigate +1. So we rule out this top equation because this top equation talks about -1. We don't have nothing to do with this. Them two you're going to work with. I'm going to always work with my known and then work with the unknown. Work with my known first. Not noun, you know. Not N-O-U-N, but K-N-O-W-N, my known value. So anyway, in the function to the right of 1, I see x, I'm putting 1. So 5 times 1 is 5, plus 2 plus 7 is 12. It means that the function to the left of 1, given by the function ax minus ax plus b, that must also be equal to 12. see Tracy, has to be equal to it. Because it said to you that A and B are continuous over all the intervals. Negative infinity to positive infinity. Very important. Very, 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 very important. Now, when the big boss start talk and start jumping to simultaneous equation, I say, what? Man, look like you want box bird out of my mouth. Yeah, man. Whenever we have two equations in two unknown, we solve simultaneously. So yes, Mickey, I heard you, but you did jump way too far ahead of us. So anytime you have two equations in two unknowns, we solve simultaneously. Anytime you have two equations, two unknowns, we solve simultaneously. And then Nikki, I jump in and say, yes, you're going to eliminate one of the variables and take and yeah, man, same it. So, are there any questions up to this point before I move on? Because you're going to finish the question, I'm just walking you through it. Are there any questions up to this point?
Question is, so it's like, I wouldn't just look at it to say use simultaneous. Like, how that drop in?
As I said, whenever you have two equations, negative A plus B equals 8 is one equation, and A plus B equals 12 is a second equation. Anytime you're given two equations with two unknowns, you solve simultaneously. Does that make any sense to you now?
A little bit, yes, sir.
All right. So I'm eliminating we're gonna add both equations together. We're gonna add both. Sir, why? Because when I look at it, I see negative A plus A. I will add those two variables together. What happens?
Get 0.
Very good.
Get rid of each other.
So we're gonna add them. So we're gonna get 0 plus 2b, see here, 2b, and then 12 plus 8 is equals 20. So I didn't even bother about the 0 plus 2b. Because negative A plus A is 0, B plus B is 2b, and A plus 12 is 20. So B is equals to 20 over 2. So we're getting B to be equals to 10. Can you see that?
Yes, sir.
Yes, sir.
All right, so we go on low again. What's the problem?
I think somebody said no. I said yes.
No, that there is no problem, or no that you're not following?
No, they didn't see how you got that.
I'm adding both equations. I'm adding equation 1 and equation 2. Now add them up. What is negative A plus A?
0.
Good, so that's gone. What is B plus B?
2b.
See, try to say, boom. What is 12 plus 8?
20.
Boom. So I have now simplified my equation by using the method of elimination to a simple equation.
Sir,
Yes, sir.
stop sharing notes with you, sir.
Say it again.
No, man, say stop sharing notes with you.
No, man. I had some wicked deadlines. When I say wicked deadlines, so which is one of the things that I wanted. When I told AC, let me again talk to you guys at 9 o'clock. I had some wicked deadlines that prevent me from, like this morning, I'm up from minutes 3 o'clock. From minutes 3 o'clock, I've been up because I had some wicked deadlines to meet. Now, granted, I made two of the most difficult ones, and one of them, I get an extension for tomorrow morning. That I'm gonna do tonight before I leave. But you know, so we leave class 10 o'clock. Rockstone in another half an hour we leave class. And I'm already very tired. So that's why I never get a chance to copy the stuff and send off. But yeah, man, I'm gonna send it off to you. AC, you see it now? You're saying that somebody said that they weren't seeing it. Are they now seeing it? Talk to teacher.
Whoever say you weren't seeing it, are you now seeing it?
My notification tells me that some people left the class, you know. So I'm now down to.
So I guess silence means consent. Let's move on.
I'm down to 6. All right. Chevy, you gonna sleep?
Who say me?
Yeah, man.
No, sir, me there, see me, man.
Okay. Simon, wake up.
Sir, I'm not sleeping yet.
Clearly, I have plans. Sir, I'm not sleeping yet. Tristan, what do you say?
Sir, all right.
Hey, man, you sound all right, man. You sound chirpy. You sound like you just had something very strong to drink, you know, a glass of water even. Nice. And Oliver, I know you're up and ready to go. All right, guys. Again, thanks for understanding the time to being constrained and availing your Thursday evening. It's rough, you know. It's a rough Thursday evening, but guess what? Whether or not you get me for second semester, the same thing will have to be done for the second semester because of the length of the course. We need additional time. All right. So if B, so I have a simple equation. 2b equals 20. And I want to find the value of b. I'm going to divide both sides by 2. We're dividing both sides by 2. So 2b over 2 is going to leave it b. See here, boom, b. And 20 over 2, see here, 20 over 2 is going to leave it 10. So b is equal to 10. And then we're going to substitute that into one of the two equations, either 1 or 2. I decided to put it in 2. Anywhere in 2 I see b, I'm going to put 10. This is a plus 10 equals 12. And then a is going to be equals to 12 minus 10. And a is equals to 2. So B is equal to 2 and A is equal to 2 and B is equal to 10. A is equal to 2 and B is equal to 10. How does that feel?
Interesting.
Challenging but doable.
That one is easy. And the easiest question ever see them said one there was something here.
So me sit down there. So if at first instant I sat there, I would have sat there, tried to figure it out, not getting it, move along.
And then move right along, don't.
Come back to it, still don't get it. All right, end of the exam.
No man, you can't give up so quick, man. And what I try to do, my promise to you is I try and go to as many variations as possible. Many variations as possible. And so that means anyhow them set the question on the exam paper, you'll be okay. All right. You know what to do. You know the methodology. The limit to the left and right must be equal for the function to be continuous. Otherwise, the function is discontinuous. You saw what Sir did earlier. Work with the limit to the left of -1, then work, and then the answer that you get, the limit to the right of -1, you then set it equal to that value, to that equation, to get that equation. Then repeat the matter for the x equals 3. And then you solve the equations simultaneously. So I want you to try this one for me.
Sir, I'm hungry.
Never mind. Let's soon finish. This is the last one I'm going to do. And then talk to you with some housekeeping matters. And there's something that I need to show you. Take 5 minutes and do this question for me. I do some housekeeping matters. And then call it an evening or night now. AC, you know, say that you're hungry and want to sleep and wait till you. Talk to me
Me
now.
no
You know,
work.
finish.
Me a work, sir. Me no
Oh,
finish.
your work. Okay, but you're so silent when you work. Dre. No, he left.
Stuck, you know, sir.
You stuck? How so?
Anytime I add the two equations.
Chevy, one thing. I gave you a lifeguard on Monday. We're doing a particular question. You guys got it right, you know. But I made a statement at the end of the class. Anybody remember what statement I made?
Sir.
Hello.
No, sir. Don't remember the statement you made. Sir, me a try concentrate on a complex matter here.
You're thinking too deep.
Thinking too deep.
What is to the left of -1?
2.
2, sir. So the other one will equal to 2.
When you substitute -1 into the function 2, what you get?
You substitute what, sir?
When I substitute -1, remember now, the limit as x tends to -1 to the left. When I get that function, when I get that value rather than substitute into the function, what the value I get? When I get -1 and I substitute it into the equation, what value I get?
-2. No, 2, sir. Sorry.
Oh, you know.
Because the other one is 2. The other value is 2. So I just equate it to 2.
That's what you said at the end of the class, sir. Now I remember.
That's what I said at the end of the class?
Yes, so when we do the limit, we find the limit of x to the 1 for 11, I think.
Say it again, Chevy. When I find the limit of what?
I think we did x to the 1 and of 11, and you said that whenever we find the limit of a whole number, it's always a whole number.
So the limit of a constant is the constant itself.
Yeah, the constant. Yes.
The limit of a constant is the constant itself.
Yes, sir.
Remember that. Remember that.
Yes, sir.
So
that, past that.
So what is the limit therefore? What is
2?
It is
2.
2 to the left, don't?
Yes, sir.
It has to be 2.
A negative.
Sir, how you know that? Because you don't have a variable to substitute the -1 into. So the limit of a constant is a constant itself. So guess what? If I find the limit as x tends to 1 million, trillion, billion, gazillion of 2, the answer is 2. So now what's the next step?
Move on to the right of.
The right of -1, good. And then do what?
Substitute for x.
And what am I substituting? 1 or -1?
Come on, right.
-1.
-1. So a times -1 plus b equals what?
Minus a plus b equal to.
Very good. What is the limit as x tends to 3 to the right?
What's that? 3x
minus 2.
3a.
Negative
Minus?
-2.
-2. Very good. All right. So I'm sensing that people are slowing down on me. let me just project this one quickly. So the limit of a constant is the constant itself. I'm substituting -1 into the function, so it's going to be a times -1 plus b has to be equal to this 2 right here. So this gives me my equation 1. At x equals 3, I'm doing the same thing to the right of 3, which is this. The right of 3 is going to be equal to -2.
Yes, sir.
See there? Because the limit of a constant is a constant itself. And then this other function now is going to speak to when it's to the left of 3. Anywhere in the function ax plus b, I see x equals 3. So it's going to be a times 3 plus b or 3a plus b. It must be equal to this -2 if it is continuous over the interval. If it is not continuous over the interval, then it can't equate it for them. But because I said that it's continuous, you have to equate them. And then we solve simultaneously.
That's where I stop now, sir.
Me too.
All right, look at my simultaneous solution.
Welcome about equation 3.
6.
Yeah, we come about -3. I get that, sir.
So scroll up to equation 1, let me see if I minus a plus b.
Because this method, I'm eliminating the a's first.
All right.
So if I'm eliminating the a's first, it means that I have to multiply equation 1 by 3.
Equation 1 by 3.
Also, you get
Okay.
Save. Yeah, sorry.
But then minus 3a plus 3. Okay.
So when I multiply by 3, I can get -3a plus 3b is equal to 6. See here? So equation 1 and equation 3 are related. They're first cousin. You notice my equation 2 don't change? Then I'm going to add these two equations together. -3a plus 3a is equal to 0. Those cancel out each other. And then 3a plus b is equal to 4b. Boom. And 6 plus -2 is equal to 4. Similarly, like we did up here,
Number 4b.
Sir.
this one.
I remember the maths here, and sir. Long time, supplement.
High school.
Yeah, man. Mm-hmm.
Sorry, I scrolled too fast. And that's
No, man, I lost my way a while ago, so I'm trying to find back.
okay.
So b is going to be equals to 1. And I'm going to substitute b into one of the equations. I selected equation 2. Anywhere in equation 2, I see x, I put b. 3a plus 1 is equal to -3. 3a is equal to -2 minus 1, -3. And then a is equals to -1 and b is equals to +1. All right. That's your minute. Go ahead.
So not in it, only but not in it. You say we substitute into equation 2, right?
Mm-hmm.
Why couldn't we substitute in equation 1? Well, we couldn't find the value of minus a.
No, man, you can't substitute in equation 1, you know. You can't substitute in 1, 2, or 3. But I am choosing to substitute it in equation 2.
Okay.
Yeah, man, it will work, man.
Sir, I heard you said earlier, if you're teaching us by calculus 2, right? As I said before, we're going, just hold me back here, sir.
I hear you, mom love. I hear you.
I'm not so receptive to maths, and you're one of the few maths teachers that I'm receptive to. And
Nice.
so far, I think you're the only maths teacher I'm receptive to at Excelsior. So
You'll be fine. And guess what? These are the only 2 math courses you need to do for the bachelor's, so you're at the right place at the right time.
okay.
All right. Yeah. So I thank you for the comments. And I mean, if any of you have any other comments, I mean, good, bad, indifferent, let me know. We are all humans and we have feelings and emotions that we need to express. I'm not going anymore. I'm sensing fatigue. What I'm going to, however, do though is to apologize for. I did request your email addresses in the WhatsApp group. They came in, I saw them, but based on the deadlines that I needed to work on, and as I said before, I have one more to work on tonight. I just want to get that one out of the way, and then I give you guys your access to Edit for Soft. You don't have to worry about it. I promise you that you'll still be able to complete the assessments on it. You will be fine. By the time you wake up tomorrow morning, God's willing, your access to Edit for Soft will be in your inbox, and you should be good to go. When I promise you that, I promise you that. Let me also hasten to say, I would have already made my contribution towards your final exam. Let me just tell you, I don't know if Mrs. Campbell tell you yet, but let me just tell you what it is. I was very frantic and worried yesterday because your examination papers now have reverted to the pre-COVID format. In COVID, you were given, say for example, 3 questions at 20 points each, plus 20 multiple choice questions, paper mark out of 30. No such luck this year. So I was, instead of asked to write 3 questions, I was asked to write 4 questions. So you're going to go into the exam, you're going to see 4 questions, and each question will be valued 30 marks. 30 marks.
How much questions are in those questions?
Sometimes they have A, B, C, D. A, B, C, D. Try not to put an E there or F, but A, B, C, D. I'm going to warn you. Select your best questions. Do we have an agreement?
Okay, sir.
2 out of 4 questions, select your best, please. Question and mix up. So look at it to see which one you have the most information about and tackle those. So I'll send all the recording as soon as it comes. I'll also share some of these notes, and I'll get you to Edit because I did ask and the information came in. I can't tell you that is everybody sent me the email, but I know I have received the email. I'm not going on a push. One of the things I want to learn about your teacher is, your teacher is very human. And just like how you guys can make mistakes and forget some stuff, don't put it past your teacher. It's the grace of God why I'm remembering. Hold on. God is call me. That's a word. All right. Big up on yourself. If there's no other comment or question,
sir,
go ahead, Papi. Go ahead.
How do they normally administer finals?
Face to face.
Remote.
So you're in where now, you say?
St. Ann.
All right. You have Brownstone coming to college that you can. Yeah. How far in St. Ann are you?
Oh, that's not that far away from me.
Right. So just go to Hunter Road, man, and you're good to go. Is where you went? Your castle?
Huntley Road. That's Huntley Road.
Hunter Road, right. Where you went? You went to York Castle?
Yes.
Aha. That's my neck of the woods, Papa. So me and you will talk offline.
All right, my boss.
Yeah, man. Big up on yourself here.
Cool.
Cool. Take care, guys.
All right, so thank you. Have a good evening.
No problem.
All right, Chief.